Lesson 8.3, solve absolute value equations algebraically. All right, this is task 3. Recall that the parent absolute value function f of x equals absolute value of x can be expressed as a piecewise defined function. F of x equals x if x is greater than or equal to 0, or f of x is equal to negative x if x is less than 0. When solving an absolute value equation, both cases must be considered. All right, solving an absolute value equation. The equation absolute value of ax plus b equals c, where c is greater than or equal to 0, is equivalent to the statement ax plus b equals c, or ax plus b equals negative c. All right, so we have an equation. Absolute value of 3x plus 1 equals 7. So let's see what we need to do here. So we got absolute value of 3x plus 1 equals 7. So the first thing we always have to do is isolate the absolute value. That means get it by itself on one side of the equal sign. So that means this positive 1 has to be subtracted. So we've got absolute value of 3x equals 7 minus 1 is 6. Now that this is isolated, now we can set it up as two equations per the definition here. Okay? So we're going to set it up as ax plus b equals c and ax plus b equals negative c. So basically we're going to say this, the absolute value of 3x. So we're going to have the positive side, 3x equals 6. And we're going to have 3x equals negative 6. Because the variable could be positive or negative. We don't know. Okay? And absolute value changes everything to a positive. Because absolute value is distance from 0. And a distance has to be positive. Alright, so we're going to say divide by 3. X equals 2. Divide by 3. X equals negative 2. All right, so our two solutions could be 2 or negative 2. All right, you can see they've went through the steps here as well to solve that absolute value equation. All right, so it says, which is the better explanation of why the solution led to two equations? Using the definition of absolute value, the absolute value of 3x is equal to either 3x or negative 3x. Using the definition of absolute value, the absolute value of 6 is equal to either 6 or negative 6. Well, 6 is always going to be equal to 6. But x, we don't know if x is positive or negative. So, should be the first thing here because it has a variable in it. All right, the equation, absolute value of 3x plus 1 equals 7, has two solutions, 2 and negative 2. The graph of f of x equals absolute value of 3x plus 1 and g of x equals 7 supports the conclusion that the solutions are negative 2 and 2. So remember in the last task, we showed that the intersection points, the x values of the intersection points are the solution. So when you graph that, you can see that negative 2 and 2 are the solutions. All right, so which is the best explanation of how the graphs support the conclusion of the solution? Absolute value of 3x plus 1 equals 7 are negative 2 and 2. All right, so there are 2 points of intersection. The x-coordinates of the points of intersection are the solutions. The y-coordinates are. All right, so the best explanation is that the x-coordinates are the solutions. All right, I'm going to get these marks over here. All right, let's look at the next question here. The equation, absolute value of 3x plus 1 equals 1, has exactly one solution, 0. Which is the better explanation of why there is only one equation to solve? Because you don't have a plus or minus 0. So that would be why you don't have 2. All right, so let's see what it says. The expression 3x must be positive. The equations 3x equals 0 and negative 3x equals 0 are equivalent. All right, because those two are both set equal to 0. Doesn't matter if you divide by 3 or negative 3, you're still going to get 0, which is one solution. All right, suppose that an absolute value equation, f of x equals c, has exactly one solution. Choose the letter or words to best complete the explanation of how the solution is related to the graph of f of x. The solution is the x-coordinate of the vertex. Okay, so when we're talking about it having only one solution, we know that the line's going to have to be intersecting at the vertex, kind of like what I showed you before. So let's hit check. But if I can get this to draw, I drew this earlier. If you got a V-shaped graph and then you have a line, that vertex is going to produce that one solution of intersection, that one intersection point. All right, so which is the best explanation of why the absolute value of 3x equals negative 1 has no solution? All right, x cannot be a fraction, 3x cannot be negative, the absolute value of a number cannot be negative. All right, so by definition, the absolute value of a number cannot be negative. How can you use a graph to support your conclusion? All right, so if you have all right, so if I want to graph something to kind of support this conclusion, I know that the absolute value is a V-shaped graph. And if it equals a negative number, remember this would be like x equals negative 1. So if we have x equals negative 1, let's say this is just, it's a bad sketch here. All right, so if we have absolute value here, and then we have x equals negative, there's no intersection point, even though that looks much further down than negative 1. But the intersection of the x's are the solution. And there's not going to be an intersection, so you're not going to have a negative solution here. Also, just straight definition of absolute value. I mean, if you're just thinking about one-dimensionally, okay, if we have 0 here and we go out 3 places, all right, and we go here 3 places, so distance from 0, say this is 3 and this is negative 3. If I want to find the distance from here to here, that distance is 3, and this distance is 3, even though that's negative 3. So that would be the absolute value, and this would be the absolute value of 3. But they're both going to equal positive 3. So you could just, like an absolute value cannot be a negative number. All right, if you have any questions, please let me know. All right, lesson 8.3, we're going to solve a few equations just so you can see the steps to go through. All right, so remember here solving out an absolute value equation. When you have the equation equals c, you're going to set that up as equal to c or negative c once you have the absolute value isolated. That's how you get your two solutions. With inequalities, if you have an inequality where it says less than c, then you're going to have a compound inequality where you're going to have the function is going to be between negative c and c. And if it's greater than c, the inequality is greater than c, then you're going to have an or statement. So it's going to be that less than negative c or that greater than c. All right, and these also can be replaced with less than or equal to or greater than or equal to. All right, let's look at a couple examples here. All right, so solve each equation algebraically. So this is an absolute value equation. Step 1 is to isolate the absolute value. So the first thing we need to do is get the absolute value by itself. So we're going to get rid of this -3. Remember, when you're solving an equation, you're kind of undoing the steps for order of operation. So we have to undo addition and subtraction first. Then we have to undo multiplication and division. So this equals 4. And then we're going to divide both sides by 2. X plus 1. Or the absolute value of x plus 1 equals 2. And now we have to set up our two equations by definition. So x plus 1 equals 2. And x plus 1 equals -2. So subtract 1. X is going to equal 1. Or -3. So there's your two solutions for that one. All right, looking at this next one, we're going to subtract 2. Always isolate your absolute value first. Absolute value of 3x minus 4 equals -1. All right, as absolute value equals a negative number, I don't have to do anything else because I know absolute value cannot be negative, so this one's going to be no solution. All right, looking at inequalities. Okay, we're going to do similar steps. We're first going to isolate the absolute value, so I'm going to add 11 to both sides first. So I'm going to have absolute value of x plus 4 less than or equal to, and that would be 8. And then I'll set up my two inequalities. X plus, I don't need the absolute value now. All right, x plus 4 less than or equal to 8. And remember, when we have an inequality, we do one extra thing, x plus 4. We switch the sign and the symbol. So we're going to do greater than or equal to -8. So then we're going to have x less than or equal to 4. And here we're going to have x greater than or equal to -12. All right, so we're going to put x in the middle. We've got -12 and we've got 4. The variable's on the left, so we bring the symbol straight down. Here we had to switch it. We moved the 12 to the other side, so we have to switch this around as well. So this would be, our solution is all x's between -12 and 4 for this absolute value inequality. All right, let's look at the next one. Let's subtract 10 from both sides. We're going to have 8 times the absolute value of x plus 4 less than, this would be -8. Divide both sides by 8. Absolute value of x plus 4 less than -1. All right, think about this. Absolute value, V-shaped graph going up. It has been translated over 4 units, but that still doesn't change the fact that it can't be less than -1. Now, if that said greater than -1, we could solve that, but this says less than -1. So again, this is one that has no solution. All right, so that's a couple examples to help you get started. If you have any questions, please let me know.